let's start with the explanation of rate changes in this case. Okay, so we'll go through all the rate changes quickly and try to understand how it actually works. Okay, so I will require two classes. One is today and tomorrow. So I will be able to finish all those things like in quick succession. All right, let's start. Okay, so as far as rates of reactions are considered, rates of reaction depend on four different factors. Okay, if you consider fifth one, that is the catalyst, that's a different thing. You have temperature, concentration, pressure, and the other one was surface area, right? These are the four qualities that you are or factors that affect the rate of reaction for the good or for the bad. Okay, so now let's try to understand how and why does the rate of a reaction is changed. Okay, how will explain like what is the process in this case. Okay, if there is any, and why is where we'll understand the theory behind it. Okay, so first thing we need to understand what is known as the collision theory. Okay, I want everyone on it. Let's write it down quickly. We will be understanding what is known as the collision theory. What is collision theory? Collision theory helps us understand the particles that must collide with each other. Okay, so when the particles collide with each other, the collision must have enough energy for it to be successful. When I say successful, that means they must collide with each other, that will result in a chemical reaction. Okay, now for that to happen, the particles must have a certain amount of energy, also known as the activation energy. What is the activation energy? It is the minimum amount of energy that colliding particles must have in order for a chemical reaction to be or a collision to be successful in this case. Is that clear? So look at the diagram below. The particles are actually moving non-stop. Okay, and this is one of the characteristic of particles of matter, that they move continuously. They do not stop for anything. They continuously move, whether they have small amount of energy or very large amount of energy. Okay, so particles in a liquid move non-stop to react. Okay, and therefore in this case we have taken magnesium and hydrochloric acid. So magnesium and atoms of magnesium will react with that of the acid in this case. Okay, so an acid particle must collide with magnesium atom and bonds must break. Okay, when that happens, what happens? What is the scenario in this case? Particles have enough energy for a successful collision. Okay, this point is extremely important. I'm again pointing this out. Okay, all right. Particles must have enough energy for collision. All right, and these are the points you need to write down as well. So the particles must collide and the bonds must break. Okay, and the second thing is particles have enough energy for a successful collision. All right. Therefore, what happens? Bonds break, reaction occurs, and new bonds are formed, giving the product in this case. But here is the thing. If the particles do not have enough energy, then the collision was not successful. So no bonds were broken and the acid particles just bounce away. Is that clear? Any doubts, any questions? Okay. Nigel, Rehan, Yuvan, clear?
Yes, sir.
All right. So if there are a lot of successful collision in a minute, then a lot of hydrogen is produced in that minute. In other words, the rate of reaction is high.